Now that you have a basic Express application up and running, in this one, you're going to configure your server to allow for incoming WebSocket connections. This means the server will be able to accept connections and we'll be setting up the client to make the connection. Then we'll have a persistent connection and we can send data back and forth, whether it's data from the server to the client or data from the client to the server, because that is the beauty of WebSockets. You can send data in either direction. Now, in order to set up WebSockets, we're going to be using a library called Socket.io. Just like Express makes it really easy to set up an HTTP server, Socket.io makes it dead simple to set up a server that supports WebSockets and to create a front end that communicates with the server. Socket.io has a back end and front end library. We're going to be using both to set up WebSockets. To get started, over inside of the terminal, let's go ahead and install the most recent version of Socket.io using npm i. The module name is socket.io, and the most recent version at 1.4.8. We'll be using the save dev flag to update the package.json file. Once this is in place, we can go ahead and make a few changes to our server file. First up, we're going to go ahead and load in the library. I'm going to make a constant called Socket.io, and I'm going to set it equal to the require statement for the Socket.io library. With this in place, we now need to integrate Socket.io into our existing web server. Currently, we use Express to make our web server. We create a new Express app, we configure our middleware, and we call app.listen. Now, behind the scenes, Express is actually using a built-in Node module called HTTP to create this server. We're going to need to use HTTP ourselves, configure Express to work with HTTP, then and only then will we also be able to add Socket.io support. Now, if that sounded like a mouthful, I promise it's actually going to be pretty easy. We only have to change a few lines to get things to work. First up, we're going to load in this module. It's called HTTP, so let's make a constant called HTTP. It's a built-in Node module, so there's no need to install it. We can simply require HTTP just like this. From here, we're going to go ahead and create a server using this HTTP library. Just below our app variable, let's make a variable called server, and what we're going to do is call http.createServer. Now, you might not know it, but you're actually already using the create server method behind the scenes. When you call app.listen on your Express app, it literally calls this exact same method, passing in the app as the argument for create server. Create server takes a function. This function looks really similar to one of our Express callbacks. It gets called with a request and a response. Now, as I mentioned, HTTP is actually used behind the scenes for Express. They're integrated so much so that you can actually provide the app as the argument, and we are done. Now, before we integrate Socket.io, let's go ahead and wrap up this change. We're now using the HTTP server as opposed to the Express server. So instead of calling app.listen, we're going to call server.listen. Once again, there's no need to change the arguments passed in here. They're exactly the same. They're built really closely to each other. So the server listen arguments are the same as the Express app.listen method arguments. Now that we have this in place, we haven't actually changed any app functionality. Our server is still going to work on port 3000, but we're still not going to have access to Socket.io. Over in the terminal, I can prove this by clearing the terminal output and starting up our server using nodemon. Nodemon server/server.js, and I'm just going to load localhost 3000 in the browser and see what I get back. Right here, what do we get? We get our HTML. Welcome to the chat app shows up. This means that our app is still working even though we're now using the HTTP server. The next thing that we're going to do is configure the server to also use Socket.io. That's the entire reason we made this change. On the next line, we're going to make a variable called IO. We'll talk about that in just a second. We're going to set it equal to a call to Socket.io, and we're going to pass in the server that we want to use with our web sockets. Right here, we have access to that server via the server variable, so we'll pass it in as the first and only argument. Now, what we get back is our WebSockets server. On here, we can do anything we want in terms of emitting or listening to events. This is how we're going to communicate between the server and the client, and we'll talk more about that in just a second. With this in place, our server is ready to go. We are ready to accept new connections. The problem is we don't have any connections to accept. When we load our web page, we're not doing anything. We're not actually connecting to the server, and we are going to need to manually run some JavaScript code to initiate that connection process. Now, when we integrated Socket.io with our server, we actually got access to a few cool things. First up, we got access to a route that accepts incoming connections, which means that we can now accept WebSocket connections, and we got access to a JavaScript library that makes it really easy to work with Socket.io on the client. This library is available at the following path: /socket.io /socket.io.js. If you load this JavaScript file in the browser, you can see it's just a really long JavaScript library. This contains all of the code we're going to need on the client to make the connection and to transfer data, whether it's server to client or client to server. What we're going to do in order to make the connection from our HTML file is load this in. I'm going to go back to localhost 3000, and now we can go ahead and move into Atom, opening up index.html, and down near the bottom of the body tag, we're going to add a script tag loading in the file we just pulled up in the browser. First up, we'll make the script tag itself, opening and closing it. And in order to load in an external file, we're going to use the source attribute providing the path. Now, this path is relative to our server. It's going to be /socket.io /socket.io.js, exactly as we typed it in the browser just moments ago. By adding the script tag, we're now loading in the library, and on the browser, we have access to all sorts of methods available because of the Socket library. One of those methods is going to let us initiate a connection request, and that's exactly what we're going to do down below. Let's add a second script tag. This time, instead of loading an external script, we're going to write some JavaScript right in line. Right in here, we can add any JavaScript, and this JavaScript is going to run right after the Socket.io library loads. A little bit later on, we'll be breaking this out into its own file, but for the moment, we can simply have our JavaScript code right inside of our HTML file. Right here, what we're going to do is call IO. IO is a method available to us because we loaded in this library. It's not native to the browser, and when we call it, we're actually initiating the request. We're making a request from the client to the server to open up a WebSocket and keep that connection open. Now, what we get back from IO is really important. We're going to want to save that in a variable called socket, just like this. This creates our connection, and it stores the socket in a variable, and this variable is critical to communicating. It's exactly what we need in order to listen for data from the server and in order to send data to the server. Now that we have this in place, let's go ahead and save our HTML file. We're going to move into the browser, and we're going to open up the Chrome Developer Tools. Now, regardless of what browser you use, whether it's IE, Safari, Firefox, or Chrome, you're going to have access to a set of developer tools, which makes it really easy to debug and see what's going on behind the scenes in your web page. We're going to be using the Chrome Developer Tools here to do a little debugging. I'd highly recommend using Chrome for these videos, just so you can follow along exactly. To open up the developer tools, we go to Settings, More Tools, Developer Tools. You can also use the keyboard shortcut as shown here for your operating system. When you open developer tools, you're going to be greeted with an overwhelming set of options. You're most likely brought to the Elements panel if you've never used the developer tools before. The panel we're going to be using right now is the Network panel. The Network panel keeps track of all of the requests made by your web page. So if I make a request for a JavaScript file, I'm going to see that in a nice list here. We're going to have to refresh the page in order to see the list of network requests. And right here, we have 6. The network request at the very top is the first one that was made, and the one at the very bottom is the last one that was made. The first one was for the page you see here. It's for the HTML file that loads welcome to the chat app. The second one is for that JavaScript file that we saw in the browser. This gives us the library and gives us access to calling that IO method, which starts the connection process. The next four are all related to starting up and maintaining that connection. With this in place, we now have that live connection between the client and the server, and we can start communicating whatever we want to communicate. Now, this communication could be anything at all. This comes in the form of an event. Events can be emitted from either the client or the server, and either the client or the server can listen for events. Let's talk about an event that might happen in an email app. In an email app, for example, the server might emit an event called new email when a new email comes in. The client is then going to listen for that event. When it fires, it'll get the new email data, and it'll render the email to the screen below the other ones. The same thing can happen the other way. Maybe the client wants to create a new email and send it to someone else. It's going to ask for the email address of the person and the message. It's then going to emit an event on the client that the server is going to listen to. So this whole server-client relationship is entirely ran via these events. Now, we're going to be creating custom events for our specific application throughout this section, but for now, we're going to look at a couple default ones that are built in that let you keep track of new users and disconnecting users. This means we'll be able to do something like greet a user when they join our application. In order to play around with this, over inside of Atom, inside of server.js, we are going to call a method on IO. IO.on. IO.on lets you register an event listener. We can listen for a specific event and do something when that event happens. One built-in event that we're going to use, the most popular one, is called connection. This lets you listen for a new connection, meaning that a client connected to the server, and it lets you do something when that connection comes in. In order to do something, you provide a callback function as the second argument, and this callback function, it's going to get called with a socket. This socket argument is really similar to the socket argument we have access to over inside of index.html. This represents the individual socket as opposed to all of the users connected to the server. Now, with this in place, we can do whatever we like. For example, I could use console.log to print a little message. New user connected. Every time a user connects to our app, we're going to print a message to the console. I'm going to go ahead and save the server.js file, move into the terminal, and you're going to see that the message actually already exists. To explain why, we need to understand one thing about WebSockets. WebSockets, as I mentioned, they are a persistent technology, meaning that the client and server, they both keep the communication channel open for as long as both of them want to. If the server shuts down, the client doesn't really have a choice, and the same thing for the client and server relationship. If I close a browser tab, the server cannot force me to keep the connection open. Now, when a connection drops, the client, it's still going to try to reconnect. When we restart the server using NodeMon, there's about 1/4 of a second of time where the server's down, and the client notices that. It says, whoa, server went down, let's try to reconnect. Eventually it reconnects, and that's why we're seeing the message right here. New user connected. I'm going to go ahead and shut down the server, and over inside of the client, you're going to see that network requests are being made right here. We're trying to reconnect to the server, and you can see they're failing because the server's not up. Now, if we go back into the terminal and we restart the server, over inside of the client, we're going to try to reconnect again. We're going to get a success result from the server, and boom, we are back just like that. Now, when we reconnect, you can see that we get the message over here, and that's why we saw it when we first added it to the server.js file. Now, the connection event also exists over in the client. That means on the client, we can do something when we successfully connect to the server. It might not happen right away. It might take a little time. Over inside of Atom, we can add this event inside of index.html right below our call to IO. Right here, we're going to call socket.on. We want to listen for an event, and this event is a little different than the one we have here. It's not on connection, it's on connect. The on method here is exactly the same as the one we used in server.js. The first argument is the event name, and the second argument, that is the callback function. In this case, we don't get access to a socket argument since we already have it right here called socket. In this case, all I'm going to do is use console.log to print a little message to the console, connected to server. Awesome. Now that we have this in place, we can go into the browser and go to a new tab in the developer tools. We're going to load the console tab. The console tab is kind of like the terminal inside of Node. If we use console.log in our client-side JavaScript code, those messages are going to show up here. As you can see, we also have some errors. These errors occurred when our server was down, as I was showing you how it reconnects. But if we refresh the page, as you're going to see, connected to server shows up right here. As soon as the connection happens, the client and the server, they both have that event fired. The client prints connected to server, and the server prints new user connected. With this in place, we've now used the event system in Socket.io. We haven't set our own custom events, but we have taken advantage of some built-in ones. The last thing we're going to talk about in this video is the disconnect event, which lets you do something on both the server and the client when the connection drops. We're going to add an event listener on the client together, and your challenge will be to do the same thing on the server. On the client, down below our connect event, we can call socket on again to listen to a new event. Once again, the name of the event here is the name of a built-in event, so it's only going to work if you type it correctly. This one is called disconnect. The disconnect event is going to fire whenever the connection drops. If the server goes down, the client's going to be able to do something. For now, that something is just going to be log a message, console.log, unable to connect. Actually, unable is the incorrect terminology. Disconnected from server. Much clearer. Now that we have this message in place, we can actually save our index.html file, go over to the browser, and we can give it a refresh to load in our new JavaScript file. I'm going to go ahead and make my browser screen just a little bit smaller so we can see it in the background of the terminal. I'm going to go to the terminal. I'm going to shut down the connection by shutting down the server, and over inside of the browser, what do we get? We get disconnected from server printing to the screen. If I restart my server over inside of the terminal, you can see we've automatically connected, and connected to server prints to the screen. Now the exact same event exists on the server. We can listen for a disconnecting client, and we can do something when they leave. In order to register this event, you are going to go into server.js, and inside of our callback, you're going to call socket.on, just like we do right here. It's the exact same signature. The first argument is the event name, it's the disconnect event, and the callback function should do something simple, like print client disconnected. Once you have that in place, what I want you to do is open up the browser and open up the terminal, then close the browser tab, and you should see the message print in the server, whatever message you happened to type here. Try to open up another browser tab, close that one, and make sure you get the same message. This message should print every time one of your browser tabs closes, assuming that browser tab had an open connection. Socket.on is your challenge. Take a moment to knock this out, test it, and when you're done, click play. All right, all you needed to do was copy the exact same signature as we used here. Socket.on takes two arguments. The first one is the name. Disconnect is the event name we're trying to listen to. And the second argument is the function to run when the event fires. This means the function to run when a socket is disconnected. In this case, all we're going to do is use console.log to print user was disconnected, just like this. And we're going to save the file, which is automatically going to restart our application. I'm going to switch to the terminal and then to the browser so I can see the terminal in the background. I'm going to open up a new tab so when I close this one, the Chrome browser doesn't close completely. I'm going to close the tab with the open connection, and right here inside of the terminal we get user was disconnected. If I open up a new tab and go to localhost 3000 live, right as I do it, new user connected prints, and as soon as I close it, bam, on the server, user was disconnected prints to the screen. Hopefully you're starting to see why WebSockets are so awesome. That instant two-way communication makes any sort of real-time application effortless to build. In the next video, we're going to get into the very, very interesting stuff. You're going to learn how to emit and listen to custom events. This means you can send any data you like from the server to the client and vice versa. Let's wrap this one up with a commit. I'm going to shut down our server, run git status, and I can see we only have modified files. So git commit with the AM flag is going to get the job done. Right here, we can add our message, add, connect, and disconnect event handlers. Awesome. I'm going to make the commit and push it up to GitHub. There's no need to deploy to Heroku just yet. With that in place, we are done. I'll see you in the next one.